as a basic outline, we've already solved questions of this form. We know how to do these already. So for example, if you had x squared equals 16, x squared we write as equals 4 squared, or you could write x squared is minus 4 squared. So you actually get two particular solutions for that. So if you had x squared equals 16, one way you can do it is square root both sides, can't you? And cancel the square. So you get x is plus or minus 4. So don't forget, when you have quadratics, very often you can get two solutions like this. Because 4 squared is 16 and minus 4 squared is also 16. So you have two possible answers. Okay, we generally solve indicial equations. That means having powers where the unknown is in the power by making the bases equal throughout the equation. Once the bases are made equal, we then compare the powers. So let's look at this here. So in these cases, the variable is in the power, not, which is quite different than this one where the variable is in the base. Okay, so it's kind of a little bit different, but it's similar to what you've been doing. Okay, and when we have surds, we can simplify them by rearrangement and then squaring both sides to remove the surd. We'll do that in a minute as well. So look at your first question here. We've got 2x equals 16. So what we try to do is change the base to be the same as this side. So 2 power x is 16. Therefore, 2 power x is equal to 2 power 4. All right. So if the base is the same, then we can conclude that the power is also the same. So that means that x must be equal to 4. If the base is different, we can't say that. So we always try to make the bases the same. So make bases equal. And then we compare the powers in that way to give x equals 4. Now in this question, B, we can't just simply make it 4 power something. So 4x equals 4 power what? You're going to end up with a bit of a mess here. It's going to be a fraction. So we try to reduce them to be the same base. So 4 is 2 squared, isn't it? But we can also make 8 base 2 as well to be 2 cubed. So in that case, we've got 2x here will be equal to 3. The bases are now both 2. So we can say, therefore, this power, 2x, must be equal to this power, which is 3. So x is 3 on 2. So in this question, C, now you've got a 1. You might get a bit confused what to do with 1. But remember, a power 0 equals 1. So anything power 0 will be equal to 1. So it was quite convenient. We can just make this 5 power 0. Because we know 5 power 0 is equal to 1. Anything power 0 is 1. So we just turn that to power 0. And then you end up having to look at the powers. So x squared minus 1 is here, and 0 is here. Okay, so once your bases are equal, you just ignore the base and you look at the powers. So then x squared equals 1, and then square root both sides. You'll get plus or minus 1 here for x. Okay, any questions? All right, so fairly straightforward. Now, in this case, you got a minus. So what I did here, I just stuck this whole thing on the other side. Okay, because there's no real rules when we have minus. If it's multiply, divide is easy to do. But because it's a minus, I just moved it, got it on this side. So then I've got 9 power x minus 1. And I've got 81 here. So then I change my 9 to 3 squared. And I change my 81 to 3 power 4. Okay, so these are the powers that you probably should learn in your head off by heart. So then we have 2x minus 2 when you expand. And 4 2s are 8x here. The bases are equal now, so ignore the base, don't need it. So then we compare the powers. So 2x minus 2 equals 8x. And when you rearrange, you'll get minus 1/3 for x, like that. Okay, so we're trying to get the powers to be the same. If they're the same, they're very easy to solve. And you already know how to make powers the same already, bases the same. You did it earlier. Okay, so in this case, we've got a fraction. So don't bother cross multiplying. What I did, I tried to simplify everything. And notice everything can be written as power 5, even 3125. That might be hard to remember, but if these three can be made power 5, probably this one as well. So you should check with your calculator. And 5 power 5 is 3125. So 125 is 5 cubed. 5 is 5. 25 is 5 squared. 3125 is 5, 5. So then I had 2 3s is 6x, x minus 3. Then I expanded the bracket on the top to get 2x plus 4 and 5, 5. And then I just basically did this side and then this side here. So 6x minus negative x minus 3. We just subtract the power now because we're dividing the numbers. And then 2x plus 4 minus 5. And then those both simplify down. Here, 5x plus 3, 2x minus 1. Now we have base 5, both sides, so just ignore the base. And then we compare the powers. So they end up with minus 4 on 3 for that one. So you're not going to be able to guess these. You need a procedure for going through and solving them. Okay, so I think that one's all right. Now in questions where you have surds or square root signs or even cube root signs, I try to isolate the surd. So you want surd equals something. So surd equals something on this side. And that's what I've got already here, which is good. So now then I square both sides, and that square will cancel the surd to give 2x minus 3. And 9 squared is 81. And then you just solve it to give 42. What you should do when you get surd solutions from surd questions, take your answer and put it back in here and check that it actually works. Okay, because if this is actually, for example, negative 20, if you got x equals negative 20 and you put it back here, you're going to get a square root negative number. So obviously that solution doesn't work. Okay, but normally you may get 1 or 2 answers. You should check both of them, or whichever ones you get, you should check them. So take your number and stick back in the equation. These ones will be okay. You don't really need to check these unless you really want to. But for these surd problems, take your solution and put back and check it's okay with the square root sign. Because if that number is negative, then obviously that is not a valid solution. So that one would be cut off, for example. So here's 4 to do. I'll give you like 5 minutes. And then if you get an answer, you can tell me what you got. Do it without looking in the answer key. And then we'll go through the solutions in a minute. So in question 4, well, 3x. So we try to make 81 3 power something. So that would be 3 power 4, isn't it? 3 4s are 81. So this implies that x must equal 4 in that case. Okay, in this case, we got 128. Now, I don't worry about this being negative. We can deal with that later. But the 128 is 2 power 7 minus x. And 16 is 2 power 4, like that. And so you'll get 7 times minus x minus 7x is 2 power 4. So therefore, minus 7x must equal 4. So x must equal minus 4 on 7 for your answer there for that one. Any problems there? So they should be pretty easy for you lot. So how about question C? We've got 4 and 9. And this is a fraction too. So I'm thinking we can simplify this to 2 power 2, isn't it? So 2 squared, 3 squared. And this is 3x equals 32. That's 2 power 5. And 243, that's 3 power 5. Notice now we're going to have actually the same base. It's going to be 2/3. So we should probably fix that a bit. So 2 power 6x on 3 power 6x equals 2 on 5, 3 on 5. So now we have the same power. What I'm going to do is just make them as a bracket. So 2 on 3, 6x, and that would be 2 on 3 power 5. Okay, I could have done that earlier actually in the question. So in this case, we have the base being a fraction, which is 2/3. So that's no problem. It still can be a base. So we can say, therefore, 6x must equal 5 when we compare the two powers. So the bases are ignored at that stage. So x then is 5 on 6 for that answer there. How about question D? Anyone?
4.
4. Yeah, you get 4. That's good. Did you actually do it yourself? 4?
Yeah.
Right. So let's look at root 2. What I did with root 2, I made that 2 to the power 1/2. So change your any third like this, if you can, to 2 power 1/2. Because square root 2 means 2 to the power 1/2. Okay. And this will be x squared. Now this is 2 on 4x. So 2 is okay. So leave the 2. That's 4x. But then the 4 can be made 2 squared.
2 on 2 8. Oh, yeah.
Okay?
Yeah.
All right.
Does
So
2
then,
power by 8 works? 2 power by 8.
Power of what?
8.
8. Yeah, that would be 8, the base, yeah. You're faster than me. So you got 2 half x squared. And you got 2 4x on 2 8. Right? So what you're going to get here is 2 half x squared equals 2 4x minus 8. Okay, so I just subtracted the power because we're dividing. So then you're going to end up with this equation where you've got a half x squared equals 4x minus 8. Okay, because now the bases are the same, aren't they? So we can basically just ignore the base now. And then we compare the powers. So this power should be equal to this power here if we are saying that these are equal. Remember, the power must be the same and the base must be the same. So we try to force the base to be equal first. So we end up with a quadratic. So we could multiply both sides by 2 to give you x squared equals 8x minus 16, aren't we? So times 2 this side and times 2 this side. So x squared minus 8x plus 16 equals 0. We end up with x minus 4. X minus 4, isn't it? It's a perfect square. All right, so x equals 4 for that one. Okay, there. So minus 4, 16, minus 4 plus minus 4 minus 8. So that's question D. If you're copying that, you can copy now or wait for the video. I'll record this one as well. Okay, what about this one? This looks like one that comes out of a Thai book. When I look at this question, I'm thinking this is one as I pulled out from a Thai book. So what do you think you would do first here, anyone? 3 plus 3/8. What I did here, you don't try and expand it or anything. Don't do anything like that. But you got 3 plus 3/8, which is really just 3 and 3/8, isn't it? Okay, which is going to be 27 on 8. So this here is actually the same as 27 on 8. So do that first. I give you a few minutes, you try yourself. Because next week we'll do some item pool on these kinds of questions. So try to get used to them now. And 16 on 81. Okay, so try to change these to have the same base, if possible. See what happens. That one's not so easy, so see if you can do that one. And also remember this, I'll give you a hint. Remember this rule, A on B will be the same as B on A to power -1. Keep that in your mind when you do that. Now, I mentioned this rule here. We can use that now or a bit later, but I'm noticing we've got 27, which is 3 cubed, and 8, which is 2 cubed. And you got 3x. And this side, we've got 16, which is 2 power 4, and 81, which is 3 power 4. So this will give us 3. I could shortcut here. Let's make that 3 on 2. Now 3 3s are 9x, 3 3, 9x. Okay, so I kind of just shortcutted a little bit. I multiplied the powers here. It's the same thing. And this is 2 on 3 power 4 in the same way. Okay, so 2 power 4, 3 power 4. But now you notice that these fractions are flipped over, they're reciprocals. So one way you can deal with this is to use this idea here, where if you flip your fraction, change the power to the opposite sign, because that's actually power 1, isn't it? So when you flip AB to BA, this sign will become negative. And you can check your calculator, that's actually true. And we can work on that a bit more later to prove it. So here I will flip one or the other, it doesn't matter. So you've got 3 on 2, 9x equals 3 on 2 minus 4. So flip over your fraction here and write -4 there. Just change the power from 4 to -4. So now we actually have the same fraction, 3 on 2. That, and then, okay, I won't need to do that actually. So let's actually just compare them directly. So we have 9x must be equal to -4 because now we have the same base. So then we're going to have 9x equals -4. So x is -4 on 9 for that one there, to give you that answer there. If you're doing question F, I don't know if you're working ahead, but you would just square both sides and put a 2 there for that one. You can try that one yourself. But probably more important, let's go down to say question G, because I want to give you ones that will help you when you do the worksheet. Okay, so 8x minus 8x plus 1 plus 8x plus 2 is 228. But the confusing thing is now you have plus and minus, not multiply, divide. So it looks a bit more difficult. But what we'll try to do is change these two here, because we can actually simplify them a bit. So we've got 8x minus 8x times 81. Same, isn't it? Because when you multiply, you add the power. So I've just broken this down to 2 parts. Plus 8x times 8 squared, okay, equals 228. Yeah, you will see this in your worksheet, so worthwhile to learn. But now you notice you've got 8x here, here, and here. That looks like a common factor, doesn't it? In 3 parts. So you would have 8x bracket 8x times 1 is 8x minus 8 power 1 is 8, plus 8 squared, which is 64, equals 228. Okay, can I leave you to finish that one? I'll give you a few minutes to work on that one. But you see what I did? 8 power x is a common factor now. And when you see plus or minus, this is what I suspect you need to do here. And that may apply down here as well. I'm not sure. I have to look at that one. But in this case, yeah, when you see plus or minus signs in the question, think about factorizing. There should be a common factor somewhere. So this is a common factor. All right, so you try and finish that. And if you know what x is, let me know. So this is your chance in these Zoom classes to fix up any misunderstanding that you have. So if you don't talk, I'm just going to assume you can do it. So if you're having a problem about something, you can ask. So 8x. Now 1 minus 8 plus 64, that's 57, equals 228. Okay, so this will add up to 57. But now this is a multiplication. So to get rid of your 57, we would divide both sides by 57, wouldn't we? Like that, to cancel that one. It's not plus. If it's plus, you would just move it and change the sign. So 8x is 228 on 57, which is 4. So now you've got 8x equals 4. So it looks like we should change this to base 2. So 2 cubed x equals 2 squared. So now you've got 3x equals 2. So x is 2/3. That's right, correct. X is 2/3 for that one. For question J, we've got 2x plus 4. So how about we split that to 2x times 2, 4. 2 cubed is 8. Just leave it power 2. Plus 2x times 2, 1. X plus 1 is x plus 1. And then minus 2 power 0. Okay, so what I did here, this would be 16 times 2x equals 2x times 2 plus 2 cubed, which is 8, and 2 power 0 is 1. So this would be 7. So 2 cubed is 8 minus 2 power 0, which is 1. So that will give you 7 here. Okay, and then I brought this to the other side. So you have 16 times 2x minus 2 times 2x equals 7. So 16 times 2x minus 2x is 14 2x. So just treat your 2 power x like y or something like that. So that's 14 times 2x equals 7. And then we divide both sides by 14. That will cancel. So 2x equals 1/2. So that's going to be 2 power minus 1, which is 1/2. So x is going to be minus 1. Solve the following equation. So let's do a couple of these. So this is your root sign. And so when you have, remember, something absurd equals a number or some expression on the other side, then we will square both sides to get rid of this root sign. So at that step, you've got to square both sides. Okay, so 2x minus 5 squared of the square root will give you 2x minus 5. Okay, just cancel it. That would be 121. And 2x equals 121 plus 5 So 2x equals 126. X is going to be 126 on 2, which is going to be 63. So x will be 63 in this case. Right, so for question B, I recommend to move the 5 across to be -5. So square root 4x minus 7 is -5. To cancel your square root, we will square both sides as normal, like that. Cancel your root sign. So you'll end up with 4x minus 7 equals 25. So 4x equals 25 plus 7, which would be 32. So x equals 8. And when you do get your solution, go back, put it in here, and check there's no problems with it. So check that you get 0 when you put 8 in here. Okay, so what happens when you do that though? Do you get 8? Let's check. 4 times 8 minus 7 plus 5 should equal 0. So this is going to give you 25, isn't it? 32 minus 7 is 25, plus 5 equals 0. But what happens here then? You get 10, not 0. So this solution actually doesn't work. So this is not a solution, not a valid solution. You could call it an extraneous solution, extraneous solution. So it's just an extra solution that doesn't mean anything. And that means that then there's actually no solution to this equation. If the only one we get doesn't work, this has no solution, no valid solution for that one. So that's why I recommend going back and checking you actually get the correct answer when you do that. What about C here? We've only got 5 minutes, so think about question C. You've got 2 square roots, yeah?
I got no solution because x 2x cancel x
Yeah,
minus x.
you're doing C, are you? Right, for question C? Yeah, because if you square both sides, which is what we recommend to do, you're going to end up with x plus 3 equals x plus 4. Can you put a number in here and make them equal? You can't, can you? Because it has to be the same number. So whatever number you put here, they're always going to be different, aren't they? So that means that x, there will be no solution. So you'll end up with 3 equals 4. What does that mean? It doesn't mean anything, does it? Because the x cancelled out, right? But you can see also when you try to put a number in here, you can't make them equal because of the 3 and 4. Yeah, so this has no valid solution as well. So when you get something down like this, 3 equals 4, and they're obviously not the same, you would have no solution. But if you got something that said 3 equals 3, that's true all the time, isn't it? 3 equals 3. So that means this is true for all values of x. True for all values of x. So for example, if you had root x plus 3 equals root x plus 3, this is always going to be true, isn't it? It doesn't matter what you put here. So if x is 1, you'll get root 4. If x is 1, you'll get root 4. Same. If x is 6, you'll get root 9. If x is 6, you'll get root 9. Always true. So this would always be true for all values of x in this case here. But when you get something silly like this, 3 equals 4, well, obviously that's not true, and it's never going to be true. It doesn't matter what you put here and what you put here. The two sides can never be equal, okay? So with this question, square both sides. This would cancel, wouldn't it? Can't cancel anything here. We can expand that. So you're going to get x squared plus 45 equals, now if we expand that, we'll get x squared minus 6x plus 9. Okay, if you expand that perfect square, your x squared is going to cancel. You're going to end up with 6x equals 9 minus 45, which is 6x equals minus 36. Then divide by 6. X would be equal to minus 6. So you need to go back to your original question and check this actually is a valid solution. So you would have minus 6 squared plus 45 equals minus 6 minus 9. So this is going to be 36 plus 45. That's going to be 81. And this is going to be 9. 9 minus 6 minus 15, isn't it? Well, what's going to happen there? That's going to be 81. And this is minus 15. So it doesn't seem to make any sense, does it? Because root 81 is 9. 9 equals minus 15. So therefore, this has no real solution as well.